Hello, this is the next video in a playlist that I'm calling Design of Experiments or General Linear Models Design of Experiments. This is part 3, illustration. We're going to use R to illustrate the theoretical ideas that we covered in part 3. Now I'm assuming you have already covered parts 1 and 2, but I need to load these commands what we've done previously. And what it is, we're following an example out of a book by Montgomery, Design and Analysis of Experiments. It's a 3rd edition, example 3.1. They look at tensile strength of fabric. So they put different percentages of cotton in different fibers and then look at the tensile strength. Tensile strength is how much pressure it takes to pull that fabric apart. So let's load all the commands that we did earlier and then jump to part 3. And here we're going to look at partitioning the sum of squares. Now here is an R summary of the analysis. So we have a treatment, there's 5 treatments, 15% cotton, 20%, 25, 30, and 35% cotton in each fabric. And then we experiment with the tensile strength, we test it. We have residual sum of squares, and so what this video is about is we're going to show how to calculate the sum of squares treatment and sum of squares residual, often called sum of squares error. And first, let's do the sum of squares treatment. Now, in quadratic form, it was y transpose mjy. Now, M is the perpendicular projection matrix on the column space of X, your design matrix. J is the perpendicular projection matrix on the column space of 1s. And this creates the sum of squares treatment. They're the same. Now the residual is y transpose I minus M, where I is the identity matrix. We run that and we get 162. Now the sum of squares total is actually y transpose I minus JY. But we could also just add the 2 previous quadratic forms, or sum of squares, and get the same thing, 636, 96. Now the degrees of freedom. I'm gonna reprint the R commands for the ANOVA table. But notice here I'm using summary.AOV. Now, previously I didn't use the .AOV because I stored the model in OWFE, which is one-way fixed effects, and it's our model of tensile strength. And R knows that it came from those commands. And so if we hit summary, then it knows it's an AOV analysis, and it goes and grabs summary.AOV and prints it. But if you don't want it to, you definitely want it to use summary.AOV, then you just use the command. And the reason I'm telling you this, when we do contrast, everything I've read is that you need to use this command to force it to make sure to use summary.AOV when you're doing the contrast. And when we get to parts 7, 8, 9, and 10, that'll be more apparent. But here I'll just print it again, and now we want to do the degrees of freedom, which is the rank of the quadratic matrix, or the matrix in quadratic form. And since it is idempotent, it can also be the trace of that matrix. So the degrees of freedom for the sum of squares total is the trace of I minus J, which is also 24. Now the residual would be the rank of I minus M, or the trace, when we get 20, and notice it's the same on the ANOVA table. The rank is the rank of M minus J, which is 4, same as the ANOVA table, or it's the trace, and we get 4 again. Now let's look, I'm going to reprint the R command there, and let's calculate the mean squared errors, and mean squared treatment, which is the sum of squares divided by its degrees of freedom. So here we take the sum of squares divided by the degrees of freedom, and we get 8.06, which is exactly the mean squared error, or mean squared residual. Now mean squared treatment is sum of squares treatment divided by the degrees of freedom. We get 118.94, same as the ANOVA table. Now the Test Statistic is the ratio of these two mean squares, which is what we get here. And so we get 1476, yep. Now the p-value is the area in the tail from that test statistic. So we're going to use the PF function, which calculates area under the F distribution. We use our test statistic F. We have numerator degrees of freedom, denominator, and we want it in the right tail. So that's what that false is. And we get the exact same p-value. So that's how you do it by scratch. And this is what we covered in the video. Now an unbiased estimate for the error variance is, actually it's the mean squared residual. So it's 8.06. This is an unbiased estimate. Unbiased estimate, or not an unbiased estimate, an estimate of the standard deviation is you just take the square root of it and we get 2.83. Now if we hit summary and then of this model, we get this format, but if we just print the model we get a different format. So we get this format. Notice we get the sum of squares and the degrees of freedom, but we don't get the mean squared errors and the F and the p-value. So we're missing some of that. But I print this because it prints the residual standard error, which is exactly what we got up here, the square root of the mean squared error, or the mean squared residual. So that's how you calculate that. And that's it. So the next video will be part 4. So I hope you enjoyed this. I sure did. Please like the video and subscribe so you don't miss the next one. Thanks. Bye.